Alright, so the last page of the practice exam. Just like the exam, 7 pages, 53 problems, same order, just got to know what to do. You are going to get a cheat sheet for this. There's more on that on Tuesday, where you'll have some time in class to hopefully work through some of that as well. What you're going to do to convert from degrees to radians is times by pi over 180 and reduce. And what you're going to want to convert from radians to degrees is to times by 180 over pi. The pi's will cancel and reduce. So in this problem, I'm going to just put pi over 180 right next to it. I know when it ends in 0, that 5 goes into it, but more specifically, that 10 also goes into it. And I got a 15, 18, 3 goes into both of those to give me negative 5 pi over 6. And that is my solution. Again, the answer to this should look like that. The answer to this should look like that. So if I times this by 180 over pi, the pi's cancel. You can literally in your calculator, and you'll have a graphing calculator to use, go 7 times 180 divided by 6. Or you can cross cancel, 6 goes into there once, 6 goes into there 30 times, and multiply across. 210 degrees. On this problem here, we've got our standard trigonometry problem. What we're talking about here is Daniel having a 25-foot ladder. Think of where a ladder is. It's not going to lean against the building like this. The ladder is going to lean against the building as the hypotenuse. So I'm going to label 25 right here. When it's leaned against the water, it forms a 55-degree angle with the ground. Think of where is the ground. The ground is not here. The ground is right here. And everything starts from horizontal when you're dealing with these elevation or depression angles. Okay. Then I'm going to try and figure out how far up the side of the building the ladder is. Up the side of the building is right here. This would be if it was along the ground or from the base of the ladder to the building. And now what I've got here, let's label the triangle. This is hypotenuse, opposite, and adjacent. So opposite and adjacent, so SOHCAHTOA, sine of the angle is opposite over hypotenuse. When the letter's up high, you multiply. X equals 25 times sine of 55. Let me plug that into my calculator right here real quick. And I get X to be 20.5 feet. Does that make sense? Yeah, if a ladder is 25 feet and it touches the house up a certain amount of feet, it's probably not going to be 5, or else it's going to look really weird to try and get up that 25-foot ladder. For the rest of these, now I'm dealing with the unit circle problems. You probably want to make sure you put this on your cheat sheet, or it may already actually be on there on the front side. And cosine, again, is the x value, tangent is y over x, and sine is the y value at those points. Negative 360 is a clockwise rotation of a full circle, 360 degrees, and the cosine is the x value there, which is 1. At 270 degrees, let's go counterclockwise, 270, there's your point, y over x. When 0 is on the bottom, it's undefined. When 0 is on top, it's 0. At 90 degrees, I'm going sine of 90, the y value is 1. That's it. That's all you got to do for those problems. And on the last problem, counterclockwise along the unit circle, sine increases. So what I want is the values to go from negative 1 to 0 to 1. If it's decrease, I'd go the other way around from 0 to 1. And sine means it's the y value. So let's look at the y values. Where does it go from negative 1 to 0 to 1? From here to here to here, or from here to here to here? Counterclockwise, again, is against the clock, so we're going to go this way. So from here to here to here. And these are the quadrants, 1, 2, 3, 4. So here to here to here goes through quadrants 4 and 1, which is why I get A for my solution. That's it. Study for the exam by using this. Check out the review, the secondary review I gave you, and the solutions that are on Google Classroom. We'll see you on Tuesday to review one more day and answer any questions you might have going in. Have a good weekend.